Theorem on a linear transformation for a statement. Let the linear transformation t from v to w is injective then injective and v1 bar, v2 bar, vk bar be a set of linearly independent vectors in V, then the T of V1, T of V2, then T of V1 bar, T of V2 bar, T of Vk bar also linearly independent in W. So given, so what is given here? The given T is a mapping from V to W is first given T is a mapping from V to W is linear transformation. This is one thing is given. Second thing, T is a mapping from V to W is injective. And third thing is given, the set V1 bar, V2 bar, Vk bar linearly independent in V. And our claim is T of V1 bar, T of V2 bar, T of Vk bar linearly independent in W. So now, three things are given here. The first, T is a mapping from V to W is linear transformation. T is a mapping from V to W is injective, and the set V1 bar, V2 bar, Vk bar is linearly independent. Now to show that this set is linearly independent, we are going to use definition here. So consider alpha 1 T of V1 bar plus alpha 2 T of V2 bar plus alpha k T of Vk bar is equal to 0 bar. So if all alpha 1, alpha 2, alpha k equal to 0, then we can say that T of V1 bar plus T of V2 bar is T of Vk bar linearly independent. Now since we can write this as T times alpha 1 V1 bar plus alpha 2 V2 bar plus alpha k Vk bar is equal to 0 bar. Now why this? Because T is linear transformation. Now linear transformation implies what? If T is a linear transformation, then T of U bar plus V bar is equal to, or in other words, already we can write this as, instead of this we can write, okay, T of U bar plus V bar is equal to T of U bar plus T of V bar, and T of KU bar is equal to K times T of U bar. So if you combine these two axioms, then we can write this as T of K1 U bar plus K2 v bar is equal to k1 times t of u bar plus k2 times t of v bar. So if you apply this property here, we write this equation in the form of t of alpha 1 v1 bar plus t of alpha 2 v2 bar. As since t is a linear transformation, this implies t of 0 bar is equal to 0 bar. So here we are going to substitute 0 bar is equal to t of 0 bar, and therefore we get t of alpha 1 v1 bar plus alpha 2 v2 bar plus dot 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 alpha k vk bar is equal to t of 0 bar. Now since t is injective, so this implies alpha 1 v1 bar plus alpha 2 v2 bar plus dot 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 alpha k vk bar is equal to 0 bar. So what is the for this step, what is the reason here given? The reason is what? The t is injective, so that is t is 1 1. So t is 1 1 implies what? T of x is equal to t of y, then x is equal to y if t is injective. We apply this definition here, so we get t of x is equal to t of y, then x is equal to y. But what is given here? But this implies alpha 1 is equal to 0, alpha 2 is equal to 0, and alpha k is equal to 0. So why? Because again, what is given, you can check here. Given is what? T of v1 bar, v2 bar, vk bar linearly independent. Linearly independent means what? If we write these vectors in this combination, we get alpha 1 is equal to 0, alpha 2 equal to 0, alpha k equal to 0. So the what is the reason here? The v1 bar, v2 bar for this step, vk bar linearly independent, and therefore what is alpha 1 alpha 2? You can see here, we start from this equation alpha 1 t of v1 bar, alpha 2 t of v2 bar, alpha k t of vk bar, and we get alpha 1 is equal to 0, alpha 2 equal to 0, alpha k equal to 0, and therefore what this implies? This implies set t of v1 bar, t of v2 bar dot 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 t of vk bar linearly independent in W. This set is what? Linearly independent, and hence the proof.